For one thing, it's really beneficial to have a much closer control over the infrastructure that you're working with. There's very few layers of abstraction between what you deploy and our infrastructure. You're literally just deploying virtual machines, very lightweight virtual machines. On top of that, you get private networking by default. So if you want to have services be public or private, you have that option. But I think the biggest thing that Fly is known for is helping with distributed apps.
Annie Sexton, developer advocate at Fly.io, explains how Fly.io simplifies cloud deployment by combining infrastructure control with a streamlined developer experience. She covers features like private networking and distributed apps for global deployment, as well as challenges like latency and data replication in distributed systems.
Hello, everyone, and welcome to the Modern Web Podcast. I'm your host, Rob Osell, VP of Innovation at This.Labs. Today, I'm excited to have my co-host, Adam Rakis. Adam, how are you doing?
Wonderful. Thank you for asking.
Great. And our other co-host, Danny Thompson. Danny, how are you doing today?
Hey, great as always. Happy to be here.
Wonderful. Today, we are going to be sitting down and talking to Annie Sexton. Annie is a developer advocate at Fly.io. Annie, how are you doing today?
I'm doing great. Thank you.
As I sort of adjust myself in my frame, I realize I set my camera. I look very small compared to you all. But as we get going, can you kind of introduce people, if they haven't heard of it already, what is Fly.io and how did you get involved?
Sure. So Fly.io, I'll give you the elevator pitch, is we're a public cloud. So we are really infrastructure, but it feels a lot like working with a standard platform as a service, right? Most people, or I don't say most people, but many developers are comfortable working with something like Render or Vercel or Heroku, which are fantastic platforms that are built on top of another public cloud, but we are the public cloud. And but we just try and make it as easy as possible to deploy any kind of software on the web.
Well, I guess let me ask this because I often hear favorable things about Fly.io, but I don't necessarily know a ton about it. What makes it, and I'm going to use a quote for this because this is what I hear pretty often, such a cool product? Like, what is so great about Fly.io that people are, I guess, impressed or raving about it when it's just, I guess, another cloud provider in that sense? Mm-hmm. What am I missing?
So for one thing, it's really beneficial to have a much closer control over the infrastructure that you're working with. There's very few layers of abstraction between what you deploy and our infrastructure. You're literally just deploying virtual machines, very lightweight virtual machines. On top of that, you get private networking by default. So if you want to have services be public or private, you have that option. But I think the biggest thing that Fly is known for is helping with distributed apps. So you can have your app distributed in regions all over the world with a single command. There's really nothing to that. And I have a really cool video that explains how we do this. I think it's really interesting. But yeah, we make it very easy to deploy your app closest to your users. So when you start to have a more geographically distributed app, being able to serve that close to your users is key. And we make that super easy.
Could you give like a real example of why somebody would want to prefer this versus, I guess, a competitor? You don't have to name a competitor, but I guess the idea being, where is this use case more applicable? Or do, yeah, we do like the spicy takes.
Yeah. Well, and I want to give just some color. I've worked at two other platforms as a service. I worked at Heroku for 5 years. I worked at Render. I think they're fantastic products. So I have a lot of opinions about like good developer experiences for developers in particular. I think one thing that cloud providers, this is not me shitting on other public clouds. This is me saying the reality of working with other infrastructures that, and people are probably going to disagree with me on this, it's not really meant for developers to use, right? Like there's a reason why DevOps is a thing. There are people who manage infrastructure, and then there are developers. And obviously, like you can't always like put people in those distinct buckets all the time. But really, other public clouds are more complicated for a reason. And so we wanted to bridge the gap between abstracting away too much control, right? We wanted to still give people a lot of the access to the actual virtual machines that are running their apps, but still have that really good developer experience where it's literally just like a single command to run your application. So I feel like we do a pretty good job of hitting that sweet spot between giving you, like handing over the keys to control the infrastructure in a way that you want, while also giving you that easy developer experience that you would want with any kind of platform as a service that's typically built on top of another cloud.
I like that. And that's interesting because I do think that a lot of developers are on teams that sort of have to grow into their DevOps situation. And you do exist in this situation where, I remember like something like a Netlify got a lot of ground early on by just having this really easy animation. Just take a folder and just drop it into your browser and we'll put the website up for you, right? And then all the way on the other side, then you just have AWS, or I guess you could say the other side is putting servers in your own closet, but you'd have AWS where it's like, here's 10,000 services, figure it out. There really is a lot of desire to have something more towards the magic, but still be drilled down. I think that's like what the magical part is whenever you try to find something that is a managed service for you, if they don't create the through lines for you to get to the underlying thing, you're going to run into that one edge case, which means you can't use it at all. And that's such a frustrating thing for a team.
Absolutely.
Would you say DigitalOcean is your closest competitor? And if so, how do you guys differ from them?
I actually feel like we get more people coming from other platforms as a service. I think a lot of times, there was definitely a period of time where, I don't know if it was when Heroku got rid of their free tier or something, but I think a lot of platforms as a service have, like a lot of passes have experienced this like Heroku migration. Everyone's just like, I need to get somewhere else. So I would have to look at the numbers to know this for certain. I would not be so bold as to say we're an AWS competitor. I am not going to say that, even though we're technically a public cloud, right? Like we're nowhere on that scale. And yet we still do actually get a lot of people who were primarily working on infrastructure, doing DevOps, who appreciate that we actually provide sort of a simpler way of managing what they need to manage. So, not to sound too much like a broken record, but we fall into that sweet spot of giving you enough control where you can do the things that you want to do and have that flexibility without it feeling overwhelming. And so we do get a lot of people, I would say, from other passes who want a little more control. I think for me, the private networking and the global distribution is a really, really big thing. The private networking is really cool, but I also think that's something when you first get started on Fly, I think plenty of people don't even think about it. They don't even think about the private networking because maybe they're just working on like a web app. They've got like a web server and like a Postgres instance or something, right? But as their apps evolve, they find they have a lot of flexibility in being able to have these controls over how their apps communicate over the private network.
Well, even with just a web app and a Postgres machine, you would use that private subnet to communicate from the web app to the Postgres box. So even for that use case, that can come in handy.
Absolutely. And in fact, I actually remember back in my support engineering days at Heroku, the number of requests, because they would just put your Postgres on the internet. It was like, it was safe enough. It was safe enough, but I got so many requests from people who are like, I keep seeing these logs where somebody's trying to log into my Postgres and they're trying to use like root as, user and password. So, that's just more annoying than anything. But yeah, absolutely. Being able to put services that shouldn't be exposed to the internet on a private network and have them easily communicate is not something to be taken for granted, honestly. I think it's a great practice, but it's not as easy to do on other platforms.
It is funny, right? Like it is very natural for people to be doing port scanning and looking for common things. But there is a feeling like when you are working on a system and you do see those logs come up, that there is a moment where you're just like nervous, even if you don't necessarily even have those vulnerabilities, but you are just nervous. It's like living by a major highway. You're just kind of like, not really in any danger, but it just feels dangerous.
Yeah, just someone looking in your window. Hi. Okay.
Well, talk to us a little bit about the distributed case a little bit more. Like what on some level, I'm kind of curious because, like, what does distributed mean when we're already working on servers and web servers and things like that? Like, what is, when we talk about distributed in this scenario, what are we talking about?
So I'll start by talking about distributed like web servers, right? Forget about data for now. The more geographically spread out your users are, the more there becomes a need to serve those applications as close to the users as possible. And so how do you do that? Well, Fly, there's literally just like a single command where you can scale your machines and you can say, I want this in Sydney, I want this in Tokyo, I want this in Virginia, whatever. And you're done. That's it. You've got instances of your app running all over the world. And then people, like if you have your app running in Sydney and you've got users from Melbourne to who want to visit your app, they're going to be routed to the Sydney instance of your app. So that really helps reduce latency and gives people a better experience. So having that, and the way that we do this, I'm debating how in depth I want to get into this. I'm not going to jump into the details about how this is implemented. I have a whole video about Anycast and Border Gateway Protocol and stuff like that, but it's really cool. It's actually how CDNs work, how they are able to route to requests to the closest instance, the closest cache of a particular asset or whatever, right? It's effectively what we do. And that makes it so that you have really low latency. And so that's one aspect of a distributed system, right? Being able to actually have a service and requests go to the nearest instance. That's not the hard part. It's not easy, but it's also not the hard part. The hard part is data, because data's chunky, right? You can't easily just like move that around all over the place, right? And we have a lot of partners that we work with. We have some offerings ourselves that make this easier, but the reality is distributed data is very hard, period, because we're talking about something that needs to be persisted, right, and stored. And you end up running into the limitations of physics when you're dealing with this stuff, because you obviously can't have just like copies of your database all over the place, because things would conflict. Like no database works that way anyways. But
sure.
But right? And so there's all sorts of different solutions for addressing that. And I think the most common one is, what like Postgres does with their single leader replication. You have one leader and you have a bunch of replicas that are read only, right? And this works because most applications read from the database way more than they write, right? And if your database does indeed write far more than it reads, then I don't know that Postgres is what you're looking for. There might be other ones that you want to use. Ones, especially if you have like if you're building a document editing app and you need people to be able to edit at the same time, right? Being able to deal with those conflicts, there are better solutions than Postgres for something like that. So, but then the way you do those, the way you handle replication is going to be different for those databases. And so making that selection based on what your app does is really, really important. But yeah.
So are you... So it sounds like Fly has offerings for the data piece, but is that really like you solve that problem second? Like there's a lot of value with just solving the non-data portion of this. So even I guess your data accesses are just a little longer in that scenario. Maybe you get a little faster reaction or whatever, because like the server's got to go pull from the central database, which might be on another continent. Is that just basically the idea? So you get some benefits, but maybe not all of it.
Can you repeat the question? I want to make sure I understand.
Yeah, no. So we were talking about how the data was hard, and I guess I was just kind of curious to the extent to which the data problem has to be solved right away, and how much of the benefit are you getting if you don't solve the data problem? Like, what is that experience? Is there still value in doing some of these distributed things, even if you're like, I can't fully understand how to solve the data portion of this quite yet?
Right. I'll say my personal opinion is that the data problem should be addressed whenever you start to scale geographically. I don't think it's something like, well, we'll put our app in servers all around the world, but then just keep our Postgres instance in Virginia. I don't think that's a good idea, because even though your requests will get sent to the closest web server, your web server then has to like leap halfway across the world, and God knows how many queries it has to make, right? So you're not actually reducing latency in that case. I think in those situations, it would most likely be better to just have your web server in a, one or two places that are close together so that they're close to your database, because that's ultimately what's going to be faster for your users. You have to sort of know where your users are and the types of traffic that you're getting, like how much of the requests going back and forth are between the server and Postgres or whatever you're using versus the requests between your user and your app. That's something for you to evaluate, because if you have more database calls than you do calls for your user, having your server all around the world is not really going to help. So for the most part, I would say in most situations, you should be thinking about keeping your data and your server as close as possible, right? And that might mean not having your app all over the world necessarily. But I will say, there's a really cool trick that I think some might actually like freak out some like database people, because it sounds like overly simplistic. But, and I wish I could say I came up with this idea. I did not. And this really is hardly a Fly specific thing at all, right? Let's say you're using Postgres and you got your leader and a bunch of replicas in the different regions. So you have replicas very close to your web server. Great. The tricky thing is, how do you know where to send a query to your database? Like, how do you know if it should be sent to the leader or to a replica? In other words, how do you know if it's a read or a write, right? Like when a user comes and makes a request, you don't know. You don't know. You might be able to guess based on what type of HTTP method they're using. Like, okay, if it's a post request, it's probably a write. If it's GET request, it's probably a read. But like, that's convention. Don't trust that shit. And so we came up with the idea of like, what if you just let your writes fail? So you basically, you've got instances of your app that talk to the closest replicas, and you pretend like every single instance of your app is the leader, or instance of your Postgres is the leader. And then when it eventually fails, because it will, right? When you try to write to a read replica, it's not going to work. Then you just redirect it to your leader, to the region where your leader is. And so Fly has this Fly replay header that you can use. So you just sort of like relay the exact same request to either a different machine, a different region, whatever it is. And so it's this really simple technique that we suggest, where you can have all your replicas in different places. And then when you like, oops, we tried to write to a read, send it over. It happens so fast. You'd think that like, ooh, performance-wise, is that really a good idea? From what we found, it works. And it's really, really simple. So distributed data can be complicated, but there are some like clever, easy solutions that make it work really well for a good chunk of apps.
Interesting. When do teams come into this problem, I suppose? Because I've been on teams before where if you've had this issue where you're in AWS and you've been editing and maintaining your infrastructure, and then somebody else joins the team and they're like, I can't find any of the infrastructure. And you like hem and haw and they screen share and they don't see anything. And then somebody finally thinks to ask, what region are you in? Oh, you're in the wrong region. I just think like this is just an extra level of thinking. I think a lot of people, it's been really trendy to talk about edge. It's been really trendy to talk about, CDNs and all this kind of stuff. But I don't know if a lot of teams have matured to the point where they are implementing these or even thinking about implementing them. So when in your mind should a team start having those conversations? Or is it that if as long as the tooling like Fly can handle it easily enough, then you can start thinking of it much earlier than maybe you had previously?
Obviously, I'm biased that, yes, if you're building on Fly, like you can think about it whenever it makes sense to for your users. Really, it depends on your business and your users and what's needed, right? If you know most of your customers, if you know that most of your customers are in the US, I mean, maybe distribute it around the US if necessary, but that might not even be the case. it's not a matter of your team so much being ready. It's about the actual product. I mean, it's going to be a challenge for your team if you're not set up on infrastructure or a platform that makes this easy. On AWS, it's tricky. It's tricky to have multi-region, particularly if you want to have that like the virtual private network. If you want your services to all live on a virtual private network, how do you do that in a distributed way? There are ways to do this. The answer is Anycast, but it's really, I think that platforms like Vercel do a pretty good job of making distribution easier. Although I think recently they kind of decided to encourage people to move away from the edge purely based on this whole data problem, which is valid. Like it's challenging, right?
Yeah, for sure.
But so long as you have the tools available to distribute your app and your team feels comfortable in that tooling, do it whenever it makes sense for your users. But I would say, I think there's still plenty of apps that, as much as this is a thing that I'm passionate about, I also fully recognize that having geographically distributed apps is not what everyone needs, right? Especially if you're just getting started. The good news is Fly makes it easy. Like the moment you're like, oh, we for some reason are getting like tons of users from France. Okay, let's scale there, right? It's dead simple. So that's a great benefit.
Yeah, I was going to ask because, I know we've talked about the distributed systems, even how teams get involved with specifically regions, but you kind of hit on a point that I was kind of wondering myself. How is, I guess, to a certain degree, Fly.io handling this when it comes to, like, how does it simplify or make it easier for someone to know whether or not they should be considering a more global approach versus regional approach, number one. But number two, latency can be a killer for, I guess, user experience, but also people that are developing the application, trying to speed up their apps. How does Fly.io use its distributed setup to, I guess, minimize latency and keep things faster and snappy for users worldwide? And are there certain considerations someone needs to make when they're developing their app around that?
I think that there's a need for a separate tool when it comes to evaluating whether or not you should be distributing your app in the first place, right? That's where analytics tools come in to see where are people accessing your app from, right? That's not a thing that Fly provides. There are people who do much better jobs at that. So that's where I would encourage people to look into. As far as how we make it easy, as I said, it's a single command to get your app running in. I mean, you could, with a single command, have your app running in every region that we have. I don't even know how many, 20, 30 plus regions. It's a lot. And we do the work to direct users to the closest instance of your app. Are you asking about the mechanics of that? Or we're just more broadly about how do you decide? Yeah. I mean, it really is a matter of examining the traffic and examining the latency, using some kind of performance monitoring tools is going to be really helpful for that. Once you start to see if the latency is purely just based on how long it takes for the request to travel, maybe that's something to look at. There are performance monitoring tools that reveal more about the innards of why a request is taking long, right? I don't know if New Relic is the hotness anymore. I don't know what the kids are using these days for that kind of thing, but they can show you this is how long the request was queuing up on your web server. It was waiting in line for this long, or how long it took for your Postgres query to execute or whatever. So there are tools that help break that down. And then part of that is also just that time to first load, trying to figure out how long it actually took to hit the server in the first place. So when you start to look at that, when you start to examine where your users are, that's what would inform my decision.
It's interesting because you make distributed stuff sound so easy that it almost seems like, what's the big deal about it?
It's hard. We make it easy, but again, doing this kind of thing on a big fancy cloud like AWS is much harder. It's harder. And especially keeping everything connected on a VPN, that's non-trivial.
Right.
But we make it very easy. And actually, I would say that like a lot of the magic is not as complicated as you think.
Yeah. Well, it's because I guess on some level, like I started this conversation by sort of talking about how, well, what does distributed mean in a world where we're already communicating with servers? Because it's like I used to work on a desktop application, and I remember when we turned it into a distributed application, and just making that transition from something that was like a monolith to something that was distributed introduced all of the principles of asynchronicity and ordering and correctness and consistency. And I think you're correctly identifying that problem gets even worse when you take a distributed system and then distribute it into replicas in different areas. Like
Yes.
that's that same problem squared. But are there any other concerns or challenges with that kind of model? Like, because it seems like on some level we already have to be a little bit careful. What if two people or people have two tabs open and they try to edit the same piece of data? Like some level we're solving some of that asynchronicity issue. But you know, if anybody's ever worked with a database that has some of this distributed nature into it already, or it has like some replicas and you have to deal with that eventual consistency issue, it's like such a nightmare from an app dev perspective to be like, how am I going to deal with this? Because you refresh it, but you're too fast over here, so you see a different balance in your account than this person does. That stuff gets to be such a headache to deal with.
It really is, and I think this is where it comes down to something I'm less informed about, which is, you know, choosing a database that's best for your needs. Now, I think in our world, Postgres is king for most situations, and there's good reasons. But in the case of a document editing thing where you have, you know, shared collaboration on something, that's really where you would want to consider databases that have multiple leaders. And they have their own rules for resolving conflicts. And that's again, I'm not as informed about the particulars about how you configure that, what the best options are. But in solving for that kind of problem on a distributed system, a lot of that comes down to choosing the right database. I think like CockroachDB, maybe Cassandra, I think can be helpful for that. But there are different types of databases that don't use single leader replication. They use multi-leader or like no leader replication, and those can be very helpful. So that's something that you have to consider. And that's separate from the technology that actually does the distributing, if that makes sense. So does that answer your question? Or if there's more I can say,
Yeah, that makes sense.
help me elaborate.
I've got it. So it sounds like Fly is really pressing hard on the distributed thing, co-locate, like global replication, which is really cool, putting your servers close to your users and keeping the data next to those distributed servers, which is awesome. What about at the other end, the really simple, for the simple side projects with no users that might one day become big? Does Fly make it easy to deploy those sorts of simple projects in one region as a simple web app?
I would say so. We have a command called fly launch, which basically does what it sounds like. Let's say you have an Astro app that you're working on. You can run fly launch, and it will generate a Docker file for you. It will add a sample fly.toml, and it will deploy your application. And should be up and running. So we have a sort of a scanner for lots of different languages, lots of different frameworks, to best evaluate what the Docker file should look like to deploy it. Because you even though we don't run containers, you ship your application in the form of an image, right? And so for that, you either needed an existing image, or you have your own Docker file in your application. And I fully recognize, especially with hobby apps, the JavaScript community, I think it's less common to use Docker. I don't know if people would disagree with that. There's lots of other languages that are like Docker is second nature to them, but in the JavaScript world, I think it's very easy to get used to working with platforms like Render or Vercel, where they just have these pre-existing runtimes. So you just push up your code, all right, and they pull the repository, and you just run in their node environment, or what, they don't have a node. What's the Vercel, like the Edge runtime? I can't remember.
Cloudflare Workers, which is their Edge runtime, yeah.
Yeah, exactly. And so they have the environment already set up for you, which, there's pros and cons to that. I do think it makes it a little bit more challenging to test locally, but, Docker has its own challenges. I think it can be a bit of a learning curve, and we recognize that, which is why we have the fly launch command. So we take care of it for you. Because there's, once you get past the basic needs of the framework, you basically don't need to touch your Docker file hardly at all. And so we make that very simple.
I mean, yeah, deploying to Cloudflare Workers does make it harder to test locally. That's one disadvantage. And also, if you start getting users, you're now poor. So being poor is not fun. So
Yeah, I agree. I agree with that.
I guess, you kind of mentioned that there is a learning curve with Docker, so you created the fly run command. I guess for developers maybe new to fly.io, probably me in the next few hours, because I'm going to try and experiment with it for a little bit. What are some of the best ways to get started? Any tips, resources you recommend, or maybe a path that you recommend trying to make like your first app with it, so that way people get comfortable with it a lot earlier on?
Build in whatever language and framework you're comfortable in, and then once you've got it configured in a way that you like it, you're running it locally, whatever, run fly launch. That's it. That's all you got to do, and it will deploy your app for you. There are some cases where you might run into some build commands that are incorrect. I hope I'm not opening myself for too much DMs here, but I actually would love to hear from the community whenever things do break. For very common frameworks, it's always helpful to know. But I think we've done a really good job at covering our bases. So I would say most cases, it's really just as simple as that one command, and then you're up and running. Really, when using Fly, we don't want you to have to think about the platform that much, because we want you to you're developers. You're developers. You should be more focused on developing your app than have to think about managing this infrastructure. Because again, at the end of the day, with Fly, you deploy an app, and an app is made up of a lot of little virtual machines with your code on it. The end, right? You can have more machines, you can have them in different places, but ultimately that's really where your code gets sent off to. And so we try to make that deployment process as simple as possible.
A bit of a meta topic here, because it feeds off of that, which is, being a developer advocate, developer experience person on a cloud platform, or a hosting platform, just feels like it's one of the hardest things ever, because you're dealing with people that are hobbyists, or more, like I said, smaller teams that are just desperately trying to get something out onto the internet at all, versus, I'm sure quite large and mature teams who are trying to put their super bespoke AWS implementation and somehow jam it into Fly. So how do you approach developer advocacy and educate and user education from that angle? Do you just have to find each person where they are, or is there some way to create an average that works for everybody?
So I don't remember where I learned this, but it has always been my philosophy that it is better to cater to maybe not the lowest common denominator, but to people with maybe less experience, or who have less complicated apps. I think that starting there is more important. So every single video that I make, some of these videos get quite technical, but every single video that I make, I write it from the mindset of, can a mid-level JavaScript developer understand this? Even when we're talking about setting up VPN peers and virtual network interfaces and kernel space, user space, stuff like that. I want to make sure that sort of a normie JavaScript developer who isn't even really that plugged into what's hip and new with the tech world, just a normie developer, can they understand what I'm talking about? I think that's always a better place to start. But a lot of the content that we make, we're pretty adamant about, when it comes to the video content we make, it's not, first of all, it's not documentation, right? Our videos are not documentation. The videos are always, hey, here's this neat thing that we did, right? And like I think I'm most proud of the video that I just put out. It's about this, like, the way that we implement, the way that we give people the ability to SSH into one of their machines. It's freaking wild. And so that's something that I think even highly technical people who are used to working on enterprise level things can appreciate. But also, if you are newer to development, it's something that you can follow along with and still think is really entertaining. So you're right, it is challenging, but I think that there are more shared challenges than people realize. You know, the ease of getting started, that's the thing that we have to be thinking about constantly. Thinking about distribution. Everyone needs a good, easy experience deploying a data store of some kind. I think there's a lot more in common than we think. It's just often on a different scale, right? But a lot of the problems are shared. So, and if we as a platform make it easy for people who are just getting started, it's sort of like, this might be a weird analogy, but like, if you've got ADHD, they've found that the more you make classrooms more accessible to people who are neurodivergent, everyone wins. And that's sort of the approach that I take to developer advocacy is don't try to be too, I don't want to say don't try to be too sophisticated, but I think one reason that my videos have done well is because that I don't assume too much, because I want to make sure that I'm meeting people where they are.
Yeah, like that, like kind of like progressive enhancement approach, right? Like it's like make it work for the common baseline. If you want to do something more specialized from there, that's fine, but don't sacrifice the baseline experience. Very cool. All right. Well, listen, as we're closing out, for anybody that's interested in finding out more about either Fly or yourself, can you let people know where they can find you online?
Yeah, you can find me on Twitter. I am _ Annie Babani _ well, I'm sure you'll have a link to it somewhere. Yeah. That's the best place to reach me, and I'd love to hear from people.
Wonderful. All right. Well, that's going to be it for us today. Thank you, everybody, for listening to this Modern Web Podcast. Thank you, of course, to our guest, Annie. As we say, the conversation does not stop here. You can find Annie on Twitter, as she said, at _ Annie Babani. That's _ ANNIE BABANNIE and another underscore. You can find me online at Robocell. As for Adam, you can find him online at Adam Rackus. Danny, you can find at DThompsonDev. As for the podcast, you can find us online at moderndotweb.com or on Twitter at modern.web. And as we close out, we'd just like to thank today's sponsor, This.Labs, one more time, who would like me to remind you that sometimes it's hard to bridge the gap between business objectives and tech implementation, and it can get messy. This. Is trusted by top names like Meta, Google, and T-Mobile, and they love helping business leaders fulfill their strategic digital initiatives. Check them out at this.co. One more time, that's THISDOT.co. All right, see you all next time.